Hello everyone, I'm going to talk about 278 first bad version. The question is, you are a product manager and currently leading a team to develop a new product. Unfortunately, the latest version of your product fails the quality check since each version is developed based on the previous version. All the versions after a bad version are also bad. Suppose you have versions 1 to and you want to find out the first bad one, which cause all the following ones to be bad. You are given an API. Okay, this is called this one, and which return whether version is bad. Implement the function to find the first bad version. You should minimize the numbers of calls the API. So the input n is equal to 5, bad is equal to 4, output is 4. So the explanation is called is bad version 3. Then we return this, which means not bad version, this one true, and following all true. Okay, so we need to find that the first one is equal to true, which means it's a bad version, then return the first bad version. Okay, so we can analyze first. We have n, right? Start from the 1 to here. Like for example, this is 5. So when we call that function, we will return the like a force, 3, 4. And this one is true, and this one is also should be true. How could we do this? Okay, we need to find the first one. So start the first one, we can start from this way, like use the for loop to find the first true, right? This is one solution. Okay, this is the easy way, like for something, then return. And for the time complexity is O(n), and the space should be O(1). Okay, so whether we have the better solution, the space will not change, right? So the space is O(1), so we can check whether something we didn't use. Okay, we didn't use, right? The use is like 1, 2, 3, 4, 5. So this is in order. Did you feel in that? So based on the in ordered, so we can use binary search to solve this problem. So second solution is use the binary search to solve this problem. Yeah, this is, then we can improve the time into the login. We can left, right? So copy here. We can have the left and the right, right? So if the, and also we can find the middle one here. The middle one here. So current here, the middle one is false, so we can let this one here. And for here, then we're going to which left is equal to the middle plus 1 to check this one. and the middle is coming here. It's equal to true, so the right should be here. Or should be here. This is when it stops. Like a middle, like a left. So we have two conditions here. I can write if the left, we call that function is bad. Is bad. We have the middle, right? It's bad. Middle equal to true equal to false, which means not. So left equal to the mid plus 1. Mid is already checked, so we don't need to do that. So if else, like which means the equal to is bad version, it's equal to true, which means we current here is like here, right? If this is a long way, the middle maybe is at here, so which means we need to move the right part. So right is equal to mid minus 1. So when it stop is at the, this happens. Left, if smaller than the right, we can keep working. Because when this here is kind of like middle, we need to check the current middle one. Sorry, whether it's true or not. We still need to check this one. And then when the left, when the right moving, they are like this, right? Like stop is right large, smaller than the left. So this way it makes sure the stop from the 0 to the left always be false. Right to the end always be true. So when they are stop, which means the left is the true. It's here like this, the first one here. So we can write the code. So we start from the first solution. Start from the is bad version. Equal to true, then return the I. Here's return the minus 1, which means not exist. We can check. Okay, oops. Oh, this one. It should be good. This is time is Owen time. Space is 01. Okay, we can now do this. So we have to improve the time complexity, right? It's time limit. Okay. So we can do the is int left is stuff from the to avoid out of boundary, we should left plus the if action this bad version is equal to false, we can left equal to mid plus 1. Now the right equal to the mid plus minus 1. And then we can return the left. Oops. Oh, forgot, yeah. And for the time complexity, TC is O1 log n, or log n. Space is O1. You can check. See, it's a binary search. So, and thank you.